I haven't talked about white dwarfs in a little while. I think it'd be pretty cool to talk about them. I put this paper up, White Dwarfs, Nova, and Stellar Youth in the General Theory. It got put onto Vixra on the 13th. I think today is the 14th. But just as a refresher, I placed white dwarfs clearly in the very beginning. They probably are a little bit further down here size-wise. But what's most important is that they're at the beginning. Astronomers in the past, they didn't have information on evolved stars, or at least they didn't think they had information on evolved stars. Mainly because they were referring to evolved stars as planets. And those who are new to this theory, the white dwarf expands greatly and then contracts and cools, and then it becomes the planet after it's lost a very large percentage of its mass, heat, and brightness. They're very dim. They don't shine very brightly in their planet stages. Anyways, a few ideas here and why I wanted to reinforce them as to why I think the white dwarfs are the beginning stages. Number one, evolved white dwarfs aren't found. If the theorizers were correct in that a white dwarf, when it cools the rest of its mass away and becomes what they call a black dwarf, we should be finding incredibly dense objects flinging large sun-like objects around as if, there was nothing there. And we don't find them anywhere. And their excuse is, well, the white dwarf turning into a black dwarf would take longer than the age of the universe. But that's just a cop-out, because the universe is eternal. We should be finding them all over the place, but the fact that we don't find evolved white dwarfs, according to their models, just signals that they don't know what actually happens to them. What actually happens to them is that they expand, and we can see these giant things in outer space. We call them blue giants, and we call them stars. Those are the later stages. The white dwarf is the beginning stage. Number two, they also have white dwarfs not being powered by fusion at all, but the leftover heat from fusion reactions long in their theorized past. So what that means is that since they don't have the beginning stages of star evolution down, they're forcing these white dwarfs to have long histories that never happened. And so what that does is when they look out at the nova and the supernova that are related to these white dwarfs, they're skewing all the information and the data to fit their belief that the white dwarf is the ending stage. See what that does? It just snowballs. It makes everything all the way down the line completely fucked up. You got to get it right the first time. That way, all the other things that are built upon it aren't also fucked up. But that's basically what's happening in astronomy now, is that they're realizing that they based a lot of their theories and ideas on information that was false to begin with, and now they're like, fuck, all this stuff is wrong. What do we do? Well, what you do is you go back and you examine the assumptions. It was assumed that white dwarfs were the ending stage of a star. But they're not. They're the beginning stages. So they have it completely backwards with these things. That being said, another reason I should put this in there, I forgot the book, Conservation of Mass. I have what's called the mass loss principle, meaning as a star cools and dies, it loses mass and it becomes smaller, less massive. That's easy, because conservation of mass says if you take the mass from an object, it becomes less massive. It's easy to explain. You have an apple in your hands, you take a bite of the apple, and the apple becomes less massive. It isn't rocket science, man. Same with stars. The stars lose their mass and they become less massive. So the fact that white dwarfs are supposedly the weight of the sun, or heavier, or lighter, or near the sun's weight, signals that they're actually very, very, very young. Also, it holds the key to understanding gravitation. And this is very, very important, and this is where I'm going as well. if white dwarfs only can be around 1.4 times the mass of the sun, if they go any higher than that, then they explode or whatever, according to Chandrasekhar, or they shrink down to become a neutron star. Let's forget all that. The whole point of it is if they're only about the weight of a single sun, and they expand outwards and can become the weight of 15 or 16 suns, and no additional mass was added to it, that means there's some property of matter which is causing that star to increase the strength of its gravitational field outside of actually becoming less massive. Or, in reverse, the star actually has all that mass, but the gravitational field is a lot weaker because of the way the masses, the atoms are interacting with each other. And that is the type of thinking that we need to do here, because there's a mystery staring at us right in his face, right in our faces, and we can work something out with it. But until mainstream astronomers, they get their actual line of evolution down and they put things in the right place, then they're never going to understand how to make a fusion reactor and have it be stable. Sure, we can blow things up, but that's hardly useful. Anyways, see, the third one I have on here, actual dead stars are composed of material that is full of electrons, such as rocks and minerals, which prevent their nuclei from interacting. So a white dwarf essentially is what's called electron degenerate matter, meaning the nuclei are so close together because their atoms, or their electrons are gone, and they can be squeezed to a really, really, really small space. That being said, actual dead stars have electrons around their nuclei, and dead star matter is rocks and minerals. It's right on the ground. You can go outside and pick it up off the ground. You're made of it, you know. And lastly, they have degenerate matter as lacking electrons, thus force the concept called electron tunneling to overcome a barrier that was never needed to begin with inside of stars that are no longer fusing matter, such as the sun. So I went off on a tangent on this. It's kind of conjectural on my part on this type of stuff right here. But what I think happens is, if there are fusion reactions happening inside of young hot stars, it's not that they're furnaces, okay? What it actually is that the electron degenerate matter is so close together that any kind of motion, additional motion to it, can make the nuclei bump into each other and cause a reaction. That's what I think novas are. I think what's happening is the white dwarf is so dense when it's born that if a meteorite or an asteroid comes and hits it, it can signal a fusion reaction because it makes those nuclei bump into each other, and then they fuse, and then boom, you have this giant cloud of crazy that happens. And then what's really interesting is that, sure, the nova happens, the supernova happens, but the whole star doesn't explode, so there's still a remnant left over. It just sloughed off a lot of matter from that outer body, nailing it. Think of the same mechanism behind a actual nuclear warhead. You have the HE, the high explosive, crushing the plutonium in the center, and that plutonium, of course, you know, it has a neutron source, and those neutrons hit that supercritical plutonium, and then it causes a chain reaction. Kind of similar to a nova in this case, and this is conjectural. Again, I have to repeat that. Is that if you have all these nuclei together inside of a white dwarf in a large area such as the Earth, and something were to hit it and jiggle it just enough that those nuclei touch, then it can send off beta and alpha particles after the fact. I have to make sure I looked that up. But and those other particles can hit others and cause them to jiggle, and then you have, you know, a nova explosion. Meaning the star itself isn't a fusion reactor because of gravity crushing things. That's not good. What it actually is you have a bunch of electron degenerate matter there, and any kind of outer body that hits it, then it can cause a fusion reaction. And that is what possibly makes all the heavy elements like gold and uranium and all that stuff. But of course they already say that supernova nucleosynthesis is there, but it isn't the star that does it. It's outer influences. And that being said, I wanted to talk about that because they're building this ITER, which is the International Thermonuclear Experimental Reactor, off the concept of a torus, and they're going to heat a plasma up to 20 million to 100 million, or I think it was 200 million degrees Kelvin, something like that. But they're doing the equivalent of just stirring a hot cup of coffee. That's not going to cause fusion reactions, and even if it does, it's not going to be self-sustaining, because fusion isn't something where you just heat something up and has the right elements there, then they cause it. Doesn't work like that. You have to have, I think it's like two independent processes. You have to have the nuclei together first, and then you take something and smack it to get it over that extra hump of energy that's needed. And then once the nuclei touch, obviously it fuses. But anyways, the summary of this is to have white dwarfs in the beginning, not the end. They don't belong down here with all the dead stars. They're in the very beginning. They're very, very hot, and they're very dense. Alright, I'll post this paper to the bottom of the page. Take it easy, y'all.